Thank you, Elon. Appreciate it. Thank you very much. How about this? Star Trek real.
Star Trek original. Yes.
Secretary of War Pete Hegseth, along with several top Pentagon officials, has just held a special meeting with SpaceX's board of directors, and the location was Starbase itself. What they saw there clearly made an impact. A massive facility built for one purpose only: to manufacture and launch the largest rockets ever made on Earth. Even Pete Hegseth himself appeared genuinely impressed, openly praising Elon Musk and his bold vision of turning science fiction into reality. So, what exactly happened during that visit? And does this signal that SpaceX is becoming critically important to the future of the U.S. Department of Defense? Let's find out in today's episode of Alpha Tech. Just yesterday, the entire production site at Starbase was effectively shut down for the whole day, all just to prepare the site and welcome a high-level government delegation. More specifically, it was a visit from the U.S. Secretary of War Pete Hegseth, joined by several senior Pentagon officials. Also present was Texas Senator John Cornyn, a key figure who has long supported NASA funding and SpaceX contracts through congressional committees. The meeting itself took place inside the Star Factory, and as you can see, the setup was surprisingly minimal. But what really grabbed everyone's attention were 6 pristine Raptor 3 engines surrounding the stage, polished to perfection. SpaceX even used blue lighting to make them stand out. Right beside them sat a massive section of Starship, already fitted with ceramic heat shield tiles. Honestly, it was the perfect way to impress the guests, not with flashy decorations, but with the hardware itself. This meeting came just days after SpaceX secured a contract worth more than $739 million from the U.S. Space Force to launch missile tracking and early warning satellites. It also marked a key stop in the nationwide Arsenal of Freedom tour, an initiative aimed at rebuilding and revitalizing America's defense industrial base. Elon Musk was the first to take the stage. He said it was an honor to welcome the delegation and briefly shared SpaceX's long-term vision: to make Star Trek real, to make Starfleet and the Starfleet Academy real, so that space isn't always just science fiction, but something that eventually becomes science fact. And at the center of that vision, he said, are the massive Starship vehicles SpaceX is building right now. To some people, this might sound like the imagination of a grown-up kid dreaming big, but not to Pete Hegseth. By that point, Hegseth had already toured Starbase himself, walking through the Megabay assembly buildings and visiting the launch pads. So, when he stepped onto the stage, he openly thanked Elon Musk and voiced his full support for that vision. Throughout his speech, Hegseth repeatedly praised SpaceX, saying,
Team, there's nothing like this in America. There's nothing like this in the world.
He was pointing to the sheer scale and speed at which SpaceX went from nothing, from scratch, to building an entire fleet of Falcon 9, Falcon Heavy, Dragon, and now Starship. Something that, in his words, he had never seen at NASA, Blue Origin, Boeing, or Lockheed Martin. He went on to say that what SpaceX has built, and continues to build, is a living example of the American spirit of innovation, proving that large-scale, high-speed manufacturing is still possible in the United States. In contrast, Hegseth criticized legacy defense contractors for spending decades chasing perfect systems. SpaceX, he argued, has shown that America needs a new playbook, one that moves faster, cuts through bureaucracy, and prioritizes innovation driven by private companies like SpaceX if the U.S. wants to maintain its technological edge. This also signals that, in 2026, the Department of Defense is heading toward a major internal overhaul, one clearly inspired by SpaceX. Starbase has become the most visible example of a fast-moving, reusable, low-bureaucracy production model that the Trump-Hegseth administration wants to apply across the entire U.S. defense system. And the first step is already taking shape, reducing reliance on slow, underperforming legacy contractors. The clearest example is Boeing and its troubled project to replace the next presidential aircraft, the VC-25B, better known as the new Air Force One. Back in 2018, Boeing signed a fixed-price contract worth $3.9 billion to convert 2 Boeing 747-8 aircraft into highly secure presidential jets, equipped with classified communications, missile defense systems, and protection against electromagnetic pulses. The company promised to deliver the first aircraft by 2024. But as of January 2026, the program has been repeatedly delayed, now pushed all the way to mid-2028. That's nearly 4 years behind the original schedule, with total costs ballooning to an estimated $5 to $6 billion. The U.S. government, and President Trump in particular, has made its frustration very clear, repeatedly and publicly criticizing Boeing. The VC-25B program has increasingly come to symbolize everything the administration sees as wrong with legacy defense contractors: slow, inefficient, and wasteful. In contrast to Boeing, SpaceX has built a long and highly effective working relationship with the U.S. Department of Defense, now referred to as the Department of War, standing out for its rapid execution, lower costs, and high reliability. Since 2020, SpaceX has captured a dominant share of missions under the National Security Space Launch, or NSSL, program for the U.S. Space Force, securing contracts worth billions of dollars. Most notably, in early 2026, SpaceX was awarded a $739 million contract for 9 critical national security satellite launches, scheduled to fly between late 2026 and 2028. Earlier, in 2025, SpaceX also won $714 million for 5 out of 7 missions in Lane 2 of NSSL Phase 3. Thanks to launch prices that are roughly 30 to 50% lower than previous alternatives, SpaceX's total NSSL contract value has now pulled far ahead of its competitors. And the fact that this delegation chose to visit Starbase sends a clear signal. The partnership is no longer just about launching satellites on Falcon 9. There's something bigger on the table, and it almost certainly involves Starship. That message came through loud and clear in a recent post by Pete Hegseth on X, where he wrote, "Starbase is a testament to the strength of American ingenuity and invention. Keep going, Elon Musk." Alongside the post were a series of photos, Hegseth standing with Elon Musk, the two shaking hands. Moments where Musk is seen explaining just how powerful the Raptor engine is and what kind of technology goes into it. There were also images of the delegation looking up in awe inside Mega Bay 2, where Ship 39 had just completed inspections and heat shield installation. It turns out there was a reason Ship 39 hadn't been rolled out to Massey's site for cryogenic testing yet. SpaceX intentionally kept it inside Mega Bay, giving the Pentagon delegation a first-hand, up-close look at just how massive this vehicle really is. And at that moment, it's hard to imagine no one asking the obvious question: what if Starship were adapted for military use? Because that idea has already been on the table for years. The most significant military application under study is the Rocket Cargo, or Point-to-Point Delivery Program, led by the U.S. Space Force, AFRL, and U.S. Transcom since 2021. The concept is simple but radical, using large, reusable rockets like Starship to transport 30 to 100 tons of cargo, or even personnel, to anywhere on Earth in under 1 hour via suborbital flight. This capability would be game-changing in high-intensity conflicts, especially in regions like the Indo-Pacific. It enables rapid resupply, emergency logistics, cargo airdrops, or even direct support to naval forces, without relying on slow and vulnerable sea or air routes. SpaceX has already received research contracts for this program, roughly $102 million starting in 2022, with additional funding allocated in fiscal year 2025 and fiscal year 2026. And Starship stands out as the leading candidate, thanks to its massive payload capacity, precise vertical landing capability, and full reusability. Imagine a Starship variant without a heat shield, because it wouldn't need to reach orbit or perform a full re-entry. Instead, it would fly suborbitally around the planet, still equipped with its aerodynamic flaps and landing legs, capable of touching down almost anywhere on Earth. While early test plans at Johnston Atoll were paused in mid-2025 due to environmental concerns, the program itself has not been canceled. The Department of Defense continues to search for alternative test locations, with a demonstration flight now targeted for late fiscal year 2025 or sometime in 2026. The DoD has also explored the idea of operating Starship under a government-owned, government-operated model for sensitive or high-risk missions, including support for cislunar operations and broader national security objectives. According to Hegseth, the ultimate goal is to restore the United States as the global leader in artificial intelligence, all in service of building what he calls the nation's 21st century fighting force.
If you talk to Elon Musk long enough, he will tell you how important hypersonics and long-range drones are, and he's 100% correct.
So, it's not hard to see why this visit to Starbase may have been more than just a tour. It could very well be a step toward deeper cooperation and the early groundwork for a dedicated, defense-focused version of Starship. In addition, Secretary of Defense Pete Hegseth has officially announced that Grok, the AI chatbot developed by Elon Musk through xAI, will be integrated into the U.S. Department of Defense network, operating alongside Google's AI systems, such as Gemini, across both unclassified and classified environments. Hegseth emphasized that Grok will go live as early as this month, and that it will be given access to all relevant data from military IT systems and intelligence databases. The goal, he said, is to turn the U.S. military into an AI-first warfighting force. He also made it clear that the Pentagon's AI will be not woke, prioritizing real combat effectiveness and operational risk-taking over ideology. This move is strategically massive for SpaceX. It further cements the company's position as a top-tier defense partner, on top of the billions of dollars it already earns from DoD contracts through satellite launches and military Starlink services. It also opens the door for access to large-scale military data, which could help train and refine AI systems that optimize rocket launches, analyze real-time Starlink data, or even support the development of Starship for defense, lunar, and Mars missions. At the same time, having xAI and Grok, chosen by the Pentagon, significantly boosts the value of Elon Musk's entire ecosystem. It attracts more investment, strengthens public-private cooperation, and creates long-term competitive advantages over traditional rivals like ChatGPT or Gemini. In short, for SpaceX, this visit to Starbase wasn't just symbolic, it was like striking gold. In today's world of tech giants, companies like Apple, Google, and Samsung all share one quiet rule for staying on top. They never stop at the current version. Take Apple, for example. The moment the iPhone 17 hits the market and starts dominating sales, Apple's engineers are already deep into work on the iPhone 18. Different teams running in parallel, all to make sure innovation never pauses. That's how they shape the future and protect their lead. And nowhere is this mindset more visible than at Elon Musk's SpaceX. Even though Falcon 9 remains the company's reliable workhorse, launching thousands of satellites into orbit every single year, SpaceX has never been satisfied with just that. Instead, they poured their energy into Starship, a gigantic spacecraft designed to take humanity back to the moon and, ultimately, to Mars. Now, as we step into 2026, we're officially entering the era of Starship version 3, a taller vehicle powered by Raptor 3 engines, with a dramatically higher payload capacity. But here's the thing. Before we've even seen the first real flight of Starship V4, SpaceX engineers are already hard at work on version 4, an even bolder design. And according to Elon Musk himself, Starship V4 could be up to 20% longer than V3. To be more specific, when Starship V3 is fully stacked, both stages together, it stands at about 124.4 meters tall. With version 4, that total height jumps to around 142 meters, which means the actual increase is closer to 14%. So, why does this difference exist? To understand that, we first need to look at Ship V4 itself, the part of the vehicle specifically upgraded for Mars missions. Once completed, the ship alone will stand about 61 meters tall, nearly 9 meters taller than V3. To put that into perspective, the ship by itself will be roughly as tall as ULA's Vulcan Centaur when fully stacked. And remember, Vulcan is officially classified as a heavy-lift rocket. And this is exactly why SpaceX keeps pushing to make Starship bigger. It's all about Mars. Because to actually reach Mars, you need a huge amount of fuel. That's the key point here. By stretching the ship by nearly 9 extra meters, SpaceX can extend the internal propellant tanks as well. As a result, Starship V4 is expected to carry up to 2,300 tons of propellant. And as you know, Mars is far. Even at its closest approach, it's about 54.6 million kilometers, or roughly 33.9 million miles from Earth. During the cruise phase, the Raptor engines don't need to run continuously. In space, there's no air drag, so the engines are only fired briefly to fine-tune the trajectory, slow down for Mars orbit insertion, and finally for landing. Technically speaking, the 1,600 tons of propellant on Starship V3 is already enough. The total delta V for a one-way trip from LEO is only around 4 to 6 kilometers per second. But there's a catch. At that delta V, the journey would take 6 to 8 months. And that's a serious problem. That much time in deep space means prolonged exposure to cosmic radiation, increasing cancer risk, almost like being exposed to repeated X-ray scans day after day. The longer the trip, the more food and water you burn through. And let's be clear, Starship is not the ISS. It doesn't have the same level of life support, redundancy, or comfort. This is where Starship V4's extra propellant really matters. With more fuel, the vehicle can perform a much harder burn when leaving LEO, pushing the delta V up to around 7 to 9 kilometers per second, or even higher. That alone could cut the travel time down to just 3 to 6 months. And that's exactly why SpaceX is equipping Ship V4 with 9 Raptor 3 engines, 3 sea-level engines, and 6 vacuum engines, generating an initial thrust of around 2,700 tons. More fuel, more thrust, more delta V. Less time exposed to space. And that's only the Mars transfer part of the story. Before any of that can happen, the vehicle still has to go through orbital refueling because those 9 Raptor engines will burn a massive amount of propellant just to escape Earth's gravity in the first place. With Starship V4, applying this same stretch configuration to tanker starships changes the equation entirely. Instead of a long chain of refueling launches, no more than 5 tanker flights would be enough to fully load a Starship depot. Once the Mars-bound Starship reaches orbit, it docks with the depot, and in just 1 to 2 hours, it can take on the full 2,300 tons of propellant. Then it's ready to head straight for Mars. Fewer tanker flights, shorter refueling time, lower risk, and in the end, a much higher chance of mission success. That's the real reason Elon Musk wants to make Starship bigger. But making Starship longer also means adding a lot more mass. So the obvious question is, does that put extra stress on Super Heavy during liftoff? The answer is no, because in version 4, it's not just the ship that gets stretched, the booster grows too. Super Heavy V4 is expected to stand about 81 meters tall, roughly the height of a 20-story building. That extra height allows it to carry up to 4,050 tons of propellant, more than 400 tons extra compared to version 3. The version we're about to see fly for the first time on Flight 12. There's still no official word on the exact engine count, but chances are SpaceX will stick with 33 Raptor 3 engines, or possibly even 35. Based on published figures, the booster could generate around 10,000 tons of liftoff thrust, roughly 3 times more powerful than Saturn V. At that point, the fully fueled ship would weigh about 2,500 tons. Add the mass of the booster itself, and the entire full stack comes in at roughly 6,700 tons. That gives Starship a thrust-to-weight ratio of about 1.49, meaning thrust exceeds gravity by nearly 49%. And that number matters a lot. The thrust-to-weight ratio, or TWR, is what decides whether a rocket can even leave the ground in the first place, and just as importantly, how it climbs once it does. If the TWR is below 1, the rocket simply can't lift off. At exactly 1, it barely holds itself up. But once you go above 1, that's when real flight begins. With Starship V4 sitting at around 1.5, the difference is huge. From the very first second of ignition, thrust outweighs gravity by nearly 50%, allowing the vehicle to rise off the pad aggressively and cleanly without hesitation. That strong initial acceleration means the upper stage can reach orbit more efficiently, burn less propellant overall, and ultimately cut down the number of tanker flights required. So, in the end, making Starship bigger isn't a drawback at all. It's actually one of the most important optimizations SpaceX is making, with only one destination in mind: Mars. And here's the really interesting part. We may not have to wait that long to see the first Starship V4 hardware appear. Elon Musk has already hinted at the timeline, saying, Starship version 4 will have 42 engines when 3 more Raptors are added to a significantly longer ship. That will fly in 2027. If that turns out to be accurate, then SpaceX is actually keeping a surprisingly steady pace. V1 in 2023 to 2024, V2 in 2025, V3 in 2026, and V4 in 2027. It almost sounds like Apple's iPhone cycle, one new version every year. Except here, we're not talking about a $1,000 smartphone. We're talking about the largest rocket system ever built. Just the cost of producing one Super Heavy and a full Starship stack is estimated at somewhere between $90 and $150 million. And the biggest chunk of that cost comes from the Raptor engines, by far the most complex and technologically demanding components in the entire system. On top of that, you've got infrastructure, facilities, and massive payroll expenses. Right now, a single Raptor engine is estimated to cost anywhere from $200,000 to about $1 million, with recent leaks suggesting it may already be below $500,000 thanks to continuous improvements like Raptor 3. For Starship V3, Super Heavy uses 33 engines, while the ship itself uses 6, meaning engine costs alone can reach $8 to nearly $40 million per stack, roughly 30 to 40% of total production cost. That may sound expensive, but it's still insanely cheap compared to traditional engines like NASA's RS-25, which costs around $100 million per engine. And in the long run, it's only going to get cheaper. In a recent tweet, Musk mentioned that once Gigabay, the massive new facility being built next to the Megabays, comes online, SpaceX could reach truly insane production volumes, maybe as high as 10,000 ships per year. Of course, that's just theoretical for now, because building 10,000 Starships a year would raise one very simple question. Where would the money even come from? And the answer is obvious. Starship won't be mass-produced at that scale until it actually creates real value for humanity, or more realistically, until it makes a lot of money for SpaceX. Over the next 3 years, SpaceX will almost certainly start scaling back Falcon 9 launches and shift more Starlink missions over to Starship. And that makes perfect sense. Starship isn't just about the Moon and Mars. Those are long-term, expensive goals. In the near term, its real job is launching satellites. Falcon 9 currently costs about $67 million per launch. Starship, on the other hand, is expected to be 6 to 10 times cheaper. Elon Musk has even floated the idea of pushing launch costs below $10 million, or, in the long run, as low as $2 to $3 million. At that point, most of the cost is basically just fuel, because Starship is designed to be fully reusable. On top of that, Starship can carry far more payload than Falcon 9. Potentially 60 to 90 Starlink satellites in a single launch. Every flight like that could save SpaceX tens of millions of dollars. Multiply that over hundreds of launches, and the business case becomes very clear. So, what comes next? Can Starship actually make money from Moon or Mars missions? Absolutely. In the future, SpaceX could secure multi-billion-dollar contracts from governments or private companies, transporting scientific equipment, building lunar bases, or even supporting resource extraction, like helium-3. Some economic analyses suggest entirely new space markets worth hundreds of billions of dollars could emerge within the next decade. From a logical standpoint, the Moon becomes the economic stepping stone, a place where SpaceX can rent out space infrastructure, orbital fuel depots, lunar refueling stations, not just for Starship, but for other spacecraft as well.